Hello everyone, my name is Haydar Deniz Sakallı and I am a freshman student at Bilkent University in the Electrical and Electronics Engineering department. In this video, I will present my Physics 101 lab project titled Effect of Surface Material and the Fatigue on the Coefficient of the Kinetic Friction. To start, just I will talk about what friction is. Friction is a resistive force that opposes motion between two surfaces. The classical model defines kinetic friction as kinetic friction related to the coefficient of kinetic friction and the normal force opposed onto that surface. And even though some physics textbooks often treat coefficient of kinetic friction as a constant, in real life it can change depending on the texture, surface deformation, and the wear. This project has two main objectives. One of them is to comparing how cotton, cardboard, and wood surfaces affect the coefficient of kinetic friction, and the other one is to determine whether repeated sliding, known as a surface fatigue, changes the friction on a cotton surface. In order to calculate the coefficient of the kinetic friction in the first part of the experiment, I used the work-energy relationship with the given formula. And to be able to apply the given formula to our system, I prepared the experiment. And in the first part, I began by measuring the mass of the sliding block using an electronic balance. And I also marked a fixed horizontal sliding distance using a meter stick. After that, I placed the chosen surface. First, it was wood, then it was cardboard, and lastly, it was the cotton. And after that, I performed the three trials. In each trial, I placed the block at the start line, gave it a consistent initial push, and recorded the motion with a stopwatch, and noted how long it took until the block has fully stopped. And I performed this trial three more times for every surface type. After three trials per surface, I calculated the coefficient of kinetic friction using the derived formula and took the average for that material. This ensured a fair comparison between three surface types. And if we come to the part B, on the part B, we must say that cotton produced the highest friction in part A, so I decided to use it for the fatigue experiment. I moved the same block back and forth 100 consecutive times across the same exact path to wear the fibers and simulate long-term use. Immediately after 100 passes, I repeated the three trial friction measurement on the worn out cotton surface. After that, I calculated the new average coefficient of kinetic friction and compared to the initial value. At the results, I calculated the coefficient of kinetic frictions as the given values. Like in the cotton, it was 0.41, in the wood, it was approximately 0.30, and in the cardboard, it was approximately 0.20. That by comparing the surface and their coefficient of kinetic friction, it can be said that rougher and deformable surfaces like cotton are more likely to generate resistance to the motion, whereas smoother and harder surfaces like cardboard are showing less opposition to the motion. And after the part B of the results, after 100 passes, the coefficient of cotton decreased to about 0.24, which is a 42% of reduction compared to the initial cotton surface. This reduction indicates that repeated sliding gradually smooths or compresses the surface fibers, lowering the microscopic interlocking that originally caused higher friction. The observation supports the hypothesis that surface fatigue can substantially alter frictional behavior, especially in materials whose texture is easily deformed over time. Also, I calculated 6 to 7% of error in my experiment. Small variations in the results likely came from slight inconsistencies in the initial push, human reaction time with stopwatch, minor inaccuracies in the aligning of the block or measuring distance, and unnatural unevenness in the surfaces. These can explain the 6 to 7% of trial to trial difference. To conclude, these experiments showed that the coefficient of kinetic friction is highly dependent on the material and significantly affected by the surface fatigue. The results matched theoretical expectations and demonstrated that friction is not a fixed value but a dynamic property shaped by surface characteristics and wear. Thank you for watching. That's it.